This lesson is about recursive sequences and factorial numbers. Part A is recursive sequences. A recursive sequence is, it needs to be given one or more of the first few terms. So you need one or more. All other terms of the sequence are then defined using previous terms. So let me simplify that a little bit for you. Basically what I'm saying here is I need the first couple of pieces of the sequence, and then everyone after that comes from those first couple. So if I can find the first couple, I can do the rest. Let's look at some examples. Number 1, I want you to write the first 5 terms. And use the pattern to write the nth term. So I want you to give me the first 5, and then I want you to give me a sub n and tell me for any one how would I define that. So I'm going to tell you that a sub 1 equals 6, and that your first couple, and that a sub k plus 1, is ak plus 1. Now this is a sub k plus 1, and this is a sub k plus a big one. That's a little bit different there. So to figure out my terms after 1, I'm going to use this. Why it's recursive is I need this first one to be able to get the second and the subsequent. So I wanted the first 5 in your pattern. Your first one is 6. To get your second one, a sub 2, that's like doing a sub 1 plus 1, where k is 1, but the term is 2. I plugged in 1 for k, so a sub 1 plus 1. Where do I get a sub 1 from? Well, I know from right here that it's 6. So I'm going to do 6 plus 1, which is 7. That's the next term in my sequence. Now, I want to do a sub 3, which is a sub 2 plus 1. That's where k is 2. That equals a sub 2 plus 1. A sub 2 is 7, we just found that, plus 1 is 8. The second term in my sequence then is 8. If I can see how that's going every time, I will notice that it's just being added by 1. So I'm going to go 9 and 10. That would be the first 5 terms. Of course, you could shove that on your paper if you'd like to. And then I want to write a sub n. So what's happening? Okay, well, they're going up by 1, so the multiple is 1. That's your n. And so if I plug in 1, I just get 1. I need to get 6. So if I add 5 to that, 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9, on and on. And this is my answer. Okay? Remember, the multiples matter. Okay, part B. Let's talk about factorial. What does that mean? We've probably talked about this a little bit before, but we're going to go in a little more detail now. And that is, factorial is in, like exclamation point, like you're shouting in. But in math, that means you're going to do 1 times 2 times 3 times 4 times blah, 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 all the way to n minus 1, all the way to n. So every term up until you get to that number that started out your whole thing, you're going to multiply. There is a special case that we need to look at, and that is 0 factorial equals 1. That's just something you need to memorize. I'm not going to go into why that works, but that is the case. Let's go ahead and look at an example. Example number 2 for today. The sequence is 2 to the nth power over n factorial. Okay, we want to find the first 5 terms begin with n equals 0. Now, we usually begin with n equals 1, but in this case, we're going to do a 0 because that's what the problem said. So a sub 0 equals 2 to the 0 power over 0 factorial. Anything to the 0 power is always 1, and 0 factorial is also 1. 1 over 1 is 1. A sub 2 to the first power over 1 factorial. 2 to the first power is 2, 1 factorial is 1, and that's 2. A sub 2, I'm getting ahead of myself. A sub 2, 2 to the second power over 2 factorial. 2 to the second is 4. 2 factorial is like saying 2 times 1. So 2 times 1 is 2. 4 over 2 is 2. So a sub 2 is also 2. Let's do a sub 3. I'll obviously want to reduce if I can. A sub 3. 2 to the third power over 3 factorial. 2 to the third is 2 times 2, which is 4, times 2, which is 8. 3 factorial is 3 times 2 times 1. 3 times 2 is 6, times 1 is 6. So I have 8 over 6, which reduces to 4 over 3. And the fifth term in the sequence, which is a sub 4, get it 1, 2, 3, 4, 5. First 5 terms, a sub 4 is 2 to the 4th power over 4 factorial. 2 to the 4th is 16. And 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is also 24. And if I reduce that, I get 2/3. And that's the first 5 terms of my sequence. Okay, I want you to evaluate some factorials because that's part of our focus today. So let me go ahead and give you 2 last little examples here. I want you to evaluate. And I want to show you some special little tricks. So if I evaluate 8 factorial over 2 factorial times 6 factorial. If I go ahead and write that out, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1 times 6 factorial, 6, 5, 4, 3, 2, 1. And you should notice that there's some stuff I can cancel. Obviously, I could multiply that all out, but I don't want to. It's too much work. So I'm going to cancel my 1s, 2s, 3, 4, 5, 6. Now I have 8 times 7 over 1 times 2. 8 times 7 is 56. 2 times 1 is 2, and 56 divided by 2 is 28. The value of that, guys, is of course your calculator can do factorial, but so can you very quickly in your head if you reduce. Let me show you one more thing. Example 4, 16 factorial over 14 factorial. I could separate that into 16 times 15 times 14 factorial, right? Because that would be 14, 13, 12, 11, 10, 9, 8, on and on and on. Over 14 factorial, and now these two pieces cancel, and I just have to do 16 times 15, which is 240. And of course, I would use my calculator for that. Your assignment number 2 is page 650. It's numbers 55 to 58, and you need to do all of those. And then 62 to 68, just do the evens on that. This is mostly practicing recursive sequences and factorial pieces. Good luck, and let me know if you have questions.